Biomedical research pushing through the night, seeking cures and breakthroughs in the fight for life. With every discovery, a beacon in the dark, guiding us closer to healing every mark.
Hello everyone, I'm Sachin Ariel. I'm currently a PhD third year graduate student in the Department of Physiology and Pharmacology at the University of Toledo. Today in this video, I'm going to show you a brief overview of my research work and try to explain some of the key important terms and key important concepts in this video. So please stay tuned. So basically, today I'll be dealing with three important terms. The first one is hypertension, second, metabolic syndrome, and the third one, chromatin remodeling. Okay, the first one is hypertension. Hypertension is one of the major risk factors for cardiovascular diseases, and as we know that cardiovascular diseases are the number one reason for the worldwide death, it is very important to address this issue. So the normal blood pressure range for the systolic is less than 120 mmHg and diastolic is less than 80 mmHg. World Health Organization defines hypertension or high blood pressure as the condition when somebody has systolic blood pressure of more than 140 mmHg and diastolic blood pressure of more than equal to 90 mmHg. There are various factors that can cause high blood pressure in people. It can be genetics, it can be environment, it can be diet, or not eating healthy diet, or somebody who is not physically active. All of these reasons can cause high blood pressure in people, and because of that high blood pressure, people are more prone to get various kinds of other cardiovascular diseases, chronic kidney disease, and many other conditions. So the next one is metabolic syndrome. Metabolic syndrome is a cluster of metabolic dysregulations which includes high blood pressure, high triglyceride level, higher body weight, high blood glucose level, and low high density lipoprotein or HDL cholesterol, which is also the good cholesterol. The person has low HDL cholesterol. So high blood pressure is one of the factors that can drive metabolic syndrome. If a person has 3 of these 5 criteria, then the person is said to have a metabolic syndrome. In US alone, 1 out of 3 adults are suffering from metabolic syndrome, and exercise is one of the major lifestyle modification which is recommended for lowering metabolic syndrome.
So, I give you a brief overview of hypertension metabolic syndrome, and now I would like to come to my research interest, what I'm working on. As I mentioned that exercise is one of the major lifestyle modification to stay healthy, but there are certain group of people who are not able to do physical activities because of various reasons, because of medical reasons or because of illness, and these group of people are more prone to develop metabolic syndrome. So when we do exercise, our body produces ketone bodies primarily by the liver in the body, and it serves as an alternate energy source in the body when the amount of glucose is down. And beta hydroxybutyrate is one of the ketone bodies that is produced by the body. So exercise increases the production of ketone body, and my lab previously showed that ketone body beta hydroxybutyrate can have blood pressure lowering effect. So we hypothesized that supplementation of beta hydroxybutyrate can lower the other signs of metabolic syndrome such as higher body weight, higher blood glucose, high blood pressure. So we want to test that. In order to test that, we fed beta hydroxybutyrate in the drinking water in our rat model, and the rat model we used was low capacity runner rat, which has metabolic syndrome. So we want to test if beta hydroxybutyrate can lower metabolic syndrome in this group of rat or not. And we found that there was significant reduction in the body weight, as we can see here. The green bar denotes the beta hydroxybutyrate fed group. There was significant decrease in the body weight, and also the fasting glucose was significantly reduced in the beta hydroxybutyrate fed group. Not only body weight and fasting glucose, but also total cholesterol was significantly reduced in the beta hydroxybutyrate fed group, and also the systolic blood pressure was significantly reduced. So as Dr. Starmer says, bam! So that's what we got to feel, because beta hydroxybutyrate was able to lower these various signs of metabolic syndrome. But our next question was, what is the mechanism behind it? So in order to know that, we first of all need to know what chromatin remodeling is, because that's where the mechanism lies. Before I talk about chromatin remodeling, first of all, I would like to take you through this here. So this is our cell, and this is the nucleus. So inside the nucleus, there are 23 pairs of chromosomes, as we all know. So if we magnify one chromosome, then actually what we see is that it is actually the tightly wounded DNA that gives chromosome its structure. In this DNA, there are proteins called histone proteins, and histone proteins are positively charged, and as we know that DNA is negatively charged. So the positive and negative interaction is what makes histones tightly wound up around the with the DNA. So this structure is called nucleosome. There are 4 pairs of histone subunits. Histone subunit H2A, H2B, H3, and H4. And also there is a linker histone which is called H1. This is how compact DNA forms the chromosome. There are various ways chromatin remodeling can occur, whether these nucleosomes can just slide from its previous place, or it can be evicted, or it can be unwrapped. So based on that, there are various processes how the relaxed state is formed from the condensed state. So now we come to the main point from which it all started. So in my study, as I mentioned before, that beta hydroxybutyrate fate group, we saw the lowering of metabolic syndrome. So how is that actually happening? Is that when beta hydroxybutyrate was supplemented, then what it was actually doing was it was able to go and bind to a particular site in histone. In my case, histone 3 subunit, lysine 9 residues, because there are amino acid residues in the histone subunit. So in this particular position, beta hydroxybutyrate was able to go and bind and form a new chromatin remodeling, or the chromatin modification, which is known as histone beta hydroxybutyrylation. BHB provides negative charge which neutralizes the charge of histones. As a result, now there is a low binding of histones with the DNA. So that now the DNA from the condensed state, it comes to the relaxed state. HMGCS2, ACA1B, CYP24, and CYP21. So these genes were activated, means they are open for transcription now, and that's how the lipid burning genes was now they were able to lower the lipid content in the body. So when the lowering of the body weight was down, also the blood pressure was going down, total cholesterol and total glucose, everything was going down from this process called histone beta hydroxybutyrylation. So now you know what chromatin remodeling is. This is the summary of my research, that when beta hydroxybutyrate was fed to the rats, then it was able to lower metabolic syndrome via a mechanism called chromatin remodeling. Thank you so much for watching the video, and I hope you learned a bit about my project. And if you have any questions, please reach out to me. Thank you so much.